Hello, this is Ertan Taskin, and this is the second part of the digital twin application on the Golden Gate Bridge. Previously, we went through the details of the CFD model and application of the CFD model with the design of experiments and creating the reduced order model. In this video, we will bring the saved functional mockup unit format of the reduced order model to a digital twin and explore different settings. So in the previous video, we left at this stage where we will bring the imported FMU model to Twin Builder, and then continue from there. Just to give you a brief idea, we will explore adding the constants to the inputs, the corresponding inputs of the model, creating the inputs and outputs, of course, first of all, and then see the response of that while changing these the velocity inputs. And then we will assign some data pair, which is just like some table, a data table, and then see the impact of that, just to check the function of the model. And then further, we'll try to get some data, real life data, and use it in the model. So let's go all these things one by one. So here is the digital twin screen. What we're going to do, we're going to import the saved FMU model before. So while doing that, we have to answer a few questions. In terms of what are the inputs and what are the outputs to the corresponding module. So inputs are already provided here, x component and y component of the velocity. And let's take a look at the outputs one by one. We have these options on different locations. So in this particular application, we will focus on the bridge components, and when we further take a look at it, what I would like to get the average static pressure on the bridge, average static pressure on the external towers, average static pressure on the internal towers, as well as the average wall shear stress on the entire bridge surface. So clicking the import, and as you see now, the Twin Builder it creates this kind of icon to me with the corresponding inputs and outputs, and I can actually put anywhere I like on the screen. So the mouse is actually carrying it, as you see. When I click the left click mouse, and then it's already put here. I think I forgot to add the fourth, but let's go through how the things are going to go with this. So I have to escape for the rest. So there you go. I have my model. Let me zoom in. So I have these outputs, right? So I have the corresponding inlets and the corresponding outlets already specified. So let's get into view and check the component libraries. On the right side of the screen, you will see the libraries are already put here with the available components, so we can explore all these elements, just like the basic elements, um, everything you may need uh, for um, for the digital twin application. Um, you can also get into the search and type it here. So I want to have constant, for example. So the corresponding constant modules or connectors are shown here. So what am I going to do? I'm going to get two of those here, right? So since I have two inputs, I'm going to connect. Let's make a connection from constant to the inlet. There you go. Now let's double click on the constant. This is the value that we're going to enter. Um, let's put some number here, and for the x component, for the y component, I have this velocity, and then the rest is hit the analyze button and um, see the results. As you see on the left right bottom, you can see the progress, how the things are going. So in fact, the simulation is complete. So actually, let's step back a little bit. In order to see the results, it might be better to create some reports first on the screen. So we have options here. So for example, in the rectangular stacked plot option, it's going to ask us what to include. And let's take a look at, let's make this a little bigger. So we can put the constants, of course, as our inputs. Also, we can take a look at we can put the outputs. So what I will do is I will continue. I will select all these outputs, and so now we have all these um, plots with us. And also you can see the corresponding outputs after I run the model. So these are the static pressure, average pressures, and on the bridge, on the towers, and the wall shear stress average. So this is actually pretty handy to see. We can always go back and change the inputs. Again, let's say I want to make a modification on my input, and after I run it, these are going to update themselves. The other good option is, of course, bringing the plots on the same screen, right? So let's assume this is a nice place for me. Zoom out, and so the inputs are already entered and outputs are going to be calculated when the model performs the simulation. As you see, the simulation continues and the corresponding predictions are shown on the screen. So, so this is one way of using the Twin Builder. Of course, if you have some constant inputs, you can immediately get your outputs. and arrange how it looks on the screen in terms of looking at the output structure with the stacked plots, etc. So let's take a look at a different application where we may have a data set and a constant. So again, this is a very similar application, and velocity y component is again a constant value. It can be however we like, right? And then now I brought a data set again from the library. When you type data pairs, you will get this, and then when you double click and characteristics and the data sets, this is the available data set. What you can do, you can add a new data set, of course. When you click here, either you can type or you can import from the CSV file or so, but I can edit the available data set. This is the data set already read in. This is again based on the CSV file. I didn't enter these manually, but you can make modifications manually, right? And this is going to be clearly visible on the screen what type of modification you do. There you go. I made this change, and I made that change, so on and so forth. It's totally up to us what to do, right? And then let's say OK, and then similarly when we hit the analyze button, in this case you see that I brought the inputs also. So inputs are on the right side. You can of course change their locations, and outputs on the left side. And so one by one the data is read, and the corresponding response with the static pressures and wall shear stresses, etc., are shown on the left. So in the next application, which will be the final part of this application, the final part of the video, we will go through how to use a real time data in terms of reading the weather data and feeding that into the digital twin. So stay tuned, and thank you for watching.